just the idea of application performance monitoring, so a little more familiar. Mm-hmm.
Do you mean server side or edge side?
Yes. Both.
But what would it be otherwise?
I mean, I think that really covers your. So I guess when you say edge side, what exactly do you mean?
Like whatever's running on your phone.
No, like phone or computer, the client side.
Oh, yeah. So it is possible to do things client side. This is specifically covering the Python integration with PySTL libraries part of this. So it's not really going to touch that, but you can do client-side telemetry, and that's basically just running something in the browser or wherever and phoning home back to your mothership there. I'm not as big of a fan of that, but usually you see that for like session replays, and that is kind of its whole ecosystem. But, okay, so if you're not familiar with OpenTelemetry, the idea is it is a kind of standardized set of protocols and semantics around getting application performance data out of your applications, because most of us probably, outside of logs or some less granular, maybe VM level metrics, don't really know what's going on in our applications. Like, maybe you have a good setup and you spend the GDP of a small country on Splunk or Datadog. But what's hard with some of those is just correlating all this information across your different services, because maybe you could tell from your application logs something interesting is happening, and then from your container or your VM metrics, you get some more signals out of that. But how do those really correlate together? So what OpenTelemetry does is really just help you move on stuff, or put all that stuff in context and just work with that data there. There's a lot of OpenTelemetry vendors out there. I use Honeycomb. That's what I'm going to use for this presentation. They're not paying me, unfortunately, but there are open source alternatives as well. I can go over some of those at the end.
What do you mean by vendors?
So a lot of companies out there will just basically work as a sink for all your OpenTelemetry data. So you send their stuff to them, they'll process it for you and let you figure out the getting insights out of it, but they'll deal with the storing it and just making it queryable and having some kind of structure beyond, okay, here's a bunch of events.
Is there an option for you to host that sort of aggregation yourself?
Oh yeah, totally.
Okay.
And something I wanted to do with this presentation is just show you what it looks like in the context specific. Oh, okay, we're good there. Of
You should zoom in.
okay.
Keep going. Keep going.
Just get.
Okay, thanks. So, what does it look like if you want to add some tracing to an application that you have? And maybe the idea of like traces and the other signals and notes out will make more sense if you look at this. So what I have here is a very bare bones example that doesn't do any of the automatic or programmatic instrumentation you can do with this library. It's just, it's a fair amount of boilerplate, I'll admit that. And it can be pretty seamless when it comes to actually instrumenting libraries and other things used by your application, but in order to just set all this up, you have to just configure it at an entry point for your app. There's really no getting around that. But really, you can have several different kinds of exporters in OTel. So on all of these, I log things out to a console so we can see like, what does this data look like when we're generating it? And then pretty much everybody that you're going to realistically send data to will support this OpenTelemetry line protocol. That's this OTLP here. So in this style of configuration, you just say, hey, here's a traces endpoint, and all it needs is a API key. And if you have your own setup, that configuration might differ, but it's all going to be pretty much like, here is this endpoint where you send your data. And then the processor, provider, all that is a little bit of a Python specific kludge, because what this does is basically runs in, I think, another processor inside your application, because they've done a lot of work in figuring out how can we make the telemetry side of things not actually interfere with what your application is doing, because you don't want to break business functionality because your observability stuff is getting hung up. So it's better that it fails and then it just does nothing than that it takes your application with it. So typically, if you want to do manual instrumentation, for each one of these, I have what's really a basic fast API app. I just copied it from the demo there, but let's say you wanted to do this and you're not using any kind of instrumenter, you would just basically define a tracer class, and anywhere you wanted to use it in your application, you just do this get tracer, and that'll instrument it with the name of the calling module. So here it's main.py, and it has...
What is a tracer?
So yeah, the tracer here is just a, I want to say, helper class for creating traces, which are one of the base units of just observability in OTel. And a trace is just an event. It's got a timestamp, it's got a duration, and a name. Like, that is all that's required of it. And it's something that you can enrich with a lot of context about what's happening in your application. So you might think,
does it have access to the rest of your Python stack frame?
That is a good question. Normally, you wouldn't really want to send that kind of information over unless you were just recording like a exception stack. But this is like a realistic example of how, let's say you want to do some kind of manual tracing inside your application, and there's not already some kind of other instrumentation set up for it. They have some really good functionality for using this as a context manager. You can also use it as a decorator around functions, which is pretty sweet. I actually don't have a good example of that, but if I just wanted to say myfunc def. I don't know why I did self there. That is just been writing too many Python classes. But yeah. So if you execute that, that will execute the content of this function, which in this case is just a no-op as this myfunc span, and then anything that happens under there will have that as the parent span. So in this one,
is it going to capture the parameters you pass it on the return values?
not by default.
Okay.
So it's really up to you to decide what sort of information do you want to capture. It also gets into like, what do you want, like, what do you want to name your fields, and how do you want to think about your values? Because one thing that's kind of easy to get into is accidentally creating like really high cardinality field names, where if you have a, just want to say, maybe like a dictionary key that is, I guess could be dynamic, and you somehow capture that in a trace, that will really blow up the amount of stuff that you're having to index. Because you can think of fields in OpenTelemetry traces as kind of like database columns and how you would want to work with it. Like, you don't want to be creating a ton of different columns for things. You want to figure out,
Is myfunc like the name of a column?
So in this case, that's actually going to be the value under the name key on an event. You know what, let me just go ahead and run this one. Okay. Yeah. Helps if you...
I didn't know Gunnicorn can do a fast API.
Yeah.
I thought you had to use UbiCore or something.
It actually runs as a little digression here, but you can just tell it to use a Unicorn worker class.
Ah.
Yeah, I was actually trying to use Granian, which is a really nice Rust Python server, but WSGI server. That's a Python application with a server for Rust. So, you know, after we make a few calls there, we get some cool trace information. And you can see, this is typically the kind of dashboard you get in any kind of APM application, like, you know, how many spans, how many traces do you get, what kind of exceptions are you seeing? But really where it's powerful is the ability to query this data. So this is a very generic example, but it's basically, okay, what is each span and how long did it take for things to happen? Well, in my case, my func is really short because it's literally just entering and then immediately returning it. But we can see, you know, there's the name that we set there.
Oh, that's really cool. Wait, can you go back to the code base?
Yeah.
So it's that with statement is nested over there, right? And that nesting is how you get the nesting within that UI.
Yeah. So each time you do start as current span, it's I think on a per, I'm gonna say thread basis. Yeah, it's pretty good about keeping the context of where things are, but yeah, it'll just create your new span in the context of the current span.
Mm-hmm.
Yeah.
Okay.
And is there any way for you to wrap up instead of having to hard code it inside like your API?
Oh yeah. This is a very naive manual implementation,
Okay.
just to show how some of the conceptual stuff works. And so, like the example in here, we can set an attribute on our span. In this case, you know, our message is hello world. It's a literal, but that could be any kind of data that's interesting to us. So if I can figure out where my message actually is. Okay, guys, so that's going to be within. So here we get index. Fucked up using the inner span. Hold on. Yeah, there we go. So here we could say, oh, here we go. There was a context manager issue, but so in that case, you know, we could say we care about what our message is, and we want to add that as span data, and then we get that as an attribute on here. And what I was saying about cardinality, so you can see the field names here. Like you really want your field names to be what is the word? Relatively consistent, so things that don't change. But so for service name, this service name could be a lot of different values, but this key is going to be relatively consistent.
But that's because you set it as under name though, right? Or is that because library not name? You said something as the name
Yeah.
attribute.
I was actually trying to think of a case where that would be a problem. I think what'll get you is in a couple of places you can if you accidentally like unpack some JSON somewhere, and those just contain keys that are dynamic, that can really blow up the amount of fields that are getting indexed. So don't do that.
Okay, you're setting an attribute there, and it's like you can only set it to one thing. It's not like a running log, like a log output.
Right. Yeah.
Okay.
You can actually do logs and metrics in here.
Okay.
So I tried to get the automatic instrumentation working in OpenTelemetry, and I'm going to say if you are doing this, it's just a pain in the ass to try and use their OpenTelemetry instrument command. I might actually.
What is the instrument command?
So it is just a helper function that gets provided with the SDK, and it'll try and dynamically load any instrumentations that you have. So if we go to our PyProject.toml here, you can see I have I have it set up for fast API, HTTPX, logging, which is actually not what you would think. It doesn't put logs into traces, it puts trace info into logs. And then here we have this at the unicorn level 2. So in theory, it should be capable of dynamically saying, hey, here's all the things that are in the environment. Let me go set those up for all the libraries. So you don't have to go and mess around with any of the boilerplate that exists in these other functions. The thing is, it's a giant pain in the ass and often doesn't work correctly. So pretty much anytime I've worked with this, I've just gone with a programmatic approach where you do end up having to do a lot of the exporter and processor boilerplate, but when it comes to the instrumenters, you just say, hey, okay, just import this into your, whatever the entry point for your application is, and they're all pretty much built the same from this base instrumenter class. You can call one instrument function, except for maybe WSGI applications where it does take the app object there.
Is that instrument app essentially middleware, as in it's going to intercept your HTTP requests and then say I got a request? Because like
Describe it as middleware.
well, it has to intercept a call at some level. Because if you just ran that fast API without wrapping it around that instrument underscore app function, then how is OpenTelemetry going to know that you received an API call?
You're right. It wouldn't. I wouldn't really describe it as like middleware in the HTTP application sense. What it does is it's pretty much just monkey patching the fast API library itself.
Okay.
To just add these tracing calls in here. So it doesn't really wrap it as much as just put its tentacles into there and yeah, so if I did as you can see, we don't really have any tracing that we manually defined around this HTTPX call or in fast API, and so if I go get our endpoint a couple times, you can see that it knows that I am in a demo. It just takes a couple seconds to get there. But so we had essentially the same trace information, but we had to do a lot less work.
Wait, go back. Wait.
Mm-hmm.
Go back to the code.
Oh yeah.
So you didn't have to do anything to the HTTPX function.
So,
It just automatically recorded the fact that you made an API call.
Yeah, so right here is correlated with
request made by like any library?
In theory, yes. So if you're using request or HTTPX or even just URL lib3 and it's got it as a dependency.
Is that why you needed to install an instrument?
Yeah. So you do need those installed in your packages to use them, get them to work. But...
As in you need to install those OLTP, the OTel instruments, in order for it to start capturing the requests with HTTPX.
Yep.
Okay.
So there is a requests instrument. Request instrument. Right?
Yeah.
Cool.
So
Yeah, there is.
if you use OpenTelemetry Bootstrap, which is another helper command that they provide if you install the SDK, it will look at what's in your environment and recommend just literally every single instrumentation for it. I don't recommend doing this because you've now got a ton of duplicate instrumentation going on.
Why is that a bad thing?
It really just increases the signal to noise ratio that you have going on. So like, you don't really need to care about the, let's say,
You don't need to know about like an async IO coroutine if that's what you want.
I mean, you might want to, but I think my example here is this URL lib one. If you have that instrumentation set up and you're using a library that uses it, you're just going to get pretty much a duplicate span for every single time you make an HTTP request in your application, and it doesn't actually really tell you much because it'll be, for the most part, the same data that's in the parent for it.
Okay, that makes sense. Is there a way to where like you can set like a logging level, like what's it called again? With the with the logging library? Because if you set you can capture the logs of third-party packages by setting a logging level. Like if I wanted to capture all the WebSocket logs, like I said, I can set a global logging level, and if I set it to like debug, it'll give me all the WebSocket logs. So is there like a version here where I don't really want to see most of my request logs, right? But then I set a flag, and now it gives me all of them.
I don't really go into it, but you can do sampling
Okay.
based on things, and I was going to cover that towards the end. So yeah, so here we did very much the same thing that we did in our manual instrumentation, except in our actual application code, outside of our setup and just doing a couple instrument calls, we don't actually have to do any work. And so what you'll probably run into is, oh, I want to do some work here, or do some work with an application and instrument it, and there is not actually something provided by the CNCF libraries. Well, it's really not that hard to
Implement your own
hook into another module and implement your own functions here. In this case, I did just a Python YAML module. It's really simple, but just wanted to show that all of these instrumenters use the same base instrumenter class, and it's a pretty straightforward function. You can do these things several ways. What I decided to was use a decorator that basically just takes a function and we give it our instance of our tracer and the name of what we want our span to be called. And then because we're not actually using the decorator, it's a little different. But on the PyYAML one, we just want to know how long did it take to load this file, which is not a super good signal, but could be interesting at scale. and then maybe what loader class are we using, so you could correlate those two, because you can pass multiple different loader implementations to the PyYAML library. And then here, maybe we want to record an exception, and that is something that OTel is actually really good for, is you can cache an exception, and you basically add all the exception information to your span. And in there, it'll change the span status as well, which ends up as, okay, you can surface this as, we know this is an error, and we can be interested in it. Yeah.
What's the performance overhead of implementing this?
Pretty low from my experience.
Cool.
They've done a lot of good work in trying to avoid performance implications here. Yeah. And then on the Python side, what we're basically doing is just replacing the module functions with our traced versions. So you just import them as an alias, and then on the reference to the module, replace the functions there with our own functions. And then to uninstrument, which I'm not really sure in what case you would call this, but it is one of the things you have to implement. It's basically just setting the unmodified versions back. So,
Wait. I'm assuming that when you set the YAML.load equals underscore trace, you have a reference to the original YAML.load function. Yeah.
Yep. Assuming I understood Python imports there. That
Okay.
might be wrong.
No, that makes sense. That makes sense.
Yeah, so
Yeah.
you can't really define like this as the function. You have to define it on the actual.
I can see why you're saying that it's not necessarily middleware. It's monkey patching it in.
Yeah, but it's really.
You're wrapping this stuff inside a decorator. Okay.
Yeah, like you're not really wrapping for an application. Like you're not intercepting anything. You're just as part of the application machinery itself.
Okay.
David, did you say what kind of speed loss you get from this? Like, I assume it's on like the microsecond or millisecond level, but do you know what the kind of overhead is in terms of speed?
I haven't really been able to profile that. I mean, for anything we've done, it hasn't really been perceptible. It runs outside of the context of your application, so there could be some resource contention. And if you have it set up with kind of a collector sidecar, it also makes the round trips really low, and then that'll handle all the buffering and sending it off to your whatever your APM provider is.
Okay.
Sorry, I'll explain what collectors are in the next one. Yeah. In this case, I don't actually have my PyYAML one. So I am just going to use the console example here. So if I do Python 3 examples. Oh wait, no. I want our custom implementation. We get a span here. And so like, well, hey, here's the loader class information we got out of our math function there. And when we're actually calling this, we're not doing anything to, enrich our telemetry information. We're just using this function like we normally would. And now we're generating that data that we want on it. And so this right here is just the console span exporter. It just prints into standard out, and it's really useful for debugging more than anything. Or I guess if you wanted to have some kind of ingest pipeline that actually used logs instead, that's a possibility, but I don't think you really see that happening too often. Because the good folks at OpenTelemetry provide this really nice sidecar called the Open Telemetry Collector. And what it lets you do is just run, I think it's a Go application, so it's relatively scalable and performant. You can just run this alongside your application. So if you want to have multiple instances of something running, maybe not all of them have to worry about setting up your connection to whatever your APM vendor is. So in this case, you just say our exporter information or our information about where we're going to send all this data can just live in our collector, and then in our application config, instead of having our honeycomb endpoint here, this just points to localhost, and then we can send that data off. And so from your application's perspective, it's going to look exactly the same because we just do some environment variable based config here.
So can you go back to the first script that you showed us?
Yeah.
So where you were configuring like the cookies, the headers and stuff, that's essentially it's saying instead of sending it to that endpoint, we're going to send it to localhost. That's the same. That environment variable is saying the same thing. Mm-hmm. Okay. Well, what's the point of sending it to that sidecar instance instead of just passing it directly to Honeycomb?
You can do some processing.
Okay.
In there. So if you wanted to do sampling, maybe you could, let's say you have realistically, you have like 20 container instances and they're all sending to a sidecar, and instead of having them all doing their own sampling and their own just connection management between Honeycomb or whatever vendor, you could just send that all to your sidecar. Your sidecar can also handle stuff like back pressure. So if there's like a network failure between that and Honeycomb, it's now just, it's one point of failure, but it's also just, now you're only dealing with that on one container instead of 20 application containers.
Can you show the Docker compose?
Oh, yeah. This just gets it running in the background. It's a really simple Docker compose here. So the way they built it, it's pretty much, you just hand it a config file and it will take care of running itself.
Okay. So is this like an endpoint where you would send all of your telemetry data before it gets past Honeycomb?
Yeah, that's usually how you do it. You see people running it as like a Kubernetes. I think it's like an operator. No,
Okay.
that's not right. It's like a Kubernetes pod that gets deployed with their application too.
Okay. Okay. So far, all I'm getting it's a very fancy logging module that sends it sends all of your logs to a remote endpoint, and then
Pretty much.
No, but like a fancy logging module is very useful because it also gives you like how long something takes to execute.
Mm-hmm. Yeah, and at the end here, I can show you like what some nastier telemetry data looks like. Let's see. And it doesn't just do traces; it does metrics as well. So a lot of the instrumentations provide their own metrics. You can make your own metrics here. The config looks pretty identical to the tracing config. You're just setting up a bunch of providers and very long class names to say, okay, here's a pipeline of things that should happen. But once you actually have that configured in your application, it's a lot simpler. So instead of tracer, you have a meter, and what does it do? It takes metrics about things. We all know what like a power, electricity meter is. Conceptually. So, and I guess when it comes to metrics, they differ because they are like they're point in time, but they don't really have a duration or anything. it's just more of like here is a quantity of some unit. So in this case, this is kind of a dimensionless unit here of work where I literally just pick a random integer and add it to our counter. So not really a real life implementation, but just get some data in there. And so if I go to our metrics data set, oh, excuse me. Kind of wondering what that would look like. It might take just a second because it will batch your metrics data and wait a little bit before sending them. Let's see.
That's useful.
Yeah. So here we go. We finally got that metric data. So you can see we have the kind of work metric that we defined here, and that loop ran for 287 times. And now we get that as some metric data. And we also get that for our fast API server here. So it's actually surprisingly heavy here. And this is actually something you could calculate from traces if you want, but in this case, just having the metrics instrumented, we get these values, and now we can do something with them. I'd say the downside of using metrics versus just figuring out this information from trace data is that it's kind of pre-compiled for a point in time, so you can't really go back and figure out how this stuff was computed or do something differently. I mean, it's just another way to get information about your system there. Okay. I'm just going to skip over this one because it's pretty much just, did you know you can add trace info to your logs if you want to know what logs correlate with what trace ID. If you're doing some more advanced stuff there.
Well, I want to see the logs instrumentation.
Okay.
I imagine if anybody already kind of like litters their entire code base with logger calls, that you can just quickly import this and then you'll get telemetry data.
I have the console exporter here, so it's a little nasty. So this just modifies the default Python logging format. So now you can see what trace did ID correlates to what log message here. So we actually go in here and say, all right, well, request generated that, and then go into our log instrumentation and find our trace ID equals S. It's like this particular trace that took 163 milliseconds corresponds to that log. So if you were doing maybe some more advanced stuff with like Splunk or just trying to cross-reference this log data, that could be pretty useful. And then separately, you can actually tell OpenTelemetry to take logs that, the Python logging framework.
Wait, go back up.
So yeah, you can tell it to take logs that the Python logging framework emits and actually forward those. Oh, okay.
That makes sense.
Yeah. This boilerplate should be looking annoyingly familiar by now. But the one difference in how it works is you get an actual logging handler, which is a Python construct of the Python logging system, and add that to your logger, and then you would use it like normally. So in this case, it's logs SDK.
So the logging handler is what's intercepting the log calls and sending it to Honeycomb, and the other instrumenters is getting the HTTPX.
Yeah. So all the instrumentation is working like normally.
Okay.
And then on the logging handler, it registers itself as basically just another log sync in Python. So whenever that log function gets called, it sends all your log syncs based on some rules. So it'll do the standard out. But it'll also send it to the APM vendor of your choice, not necessarily Honeycomb. And then you get your logs here. So I have a fake error message, but you basically get some searchable log data here. I'm not exactly sure how good the utility on logs here versus any of the more traditional log management platforms like Splunk or those, but it's definitely a thing that you can do, and I'm sure Splunk would be happy to ingest your hotel data as well.
I've never heard of Splunk.
Really? Say, I kind of like Splunk. I do a lot of networking stuff with it.
So
Great until it's a regulatory requirement.
So Splunk, so the logs SDK is just a handler essentially that you have to register with the root logger. Okay.
So yeah, all of this stuff integrates pretty smoothly in like your existing Python application. But one of the really neat things with distributing with OTel, and probably the best thing about it, is like, what if you want to trace stuff across systems? So let's say you're making a request, and that fans out to more requests to different systems, and those fan out again, and then something blows up on one of those requests. Well, if all you have is a big bucket of logs, how exactly do you correlate all that? Well, let's hope you have request IDs for every one of those, and it knows about all the other request IDs. And that's actually really what it lets you do here. So I'm going to say, okay, I have a pretty simple implementation. My service A calls my service B here. Service B, really nothing to look at. That just does our same HTTPX demo call. But in this case, we're doing a different one where we just call our local host at a different port where that service is running. And so what's going on here? Okay, let me make sure I have my console explorer off. Is a couple different things. So baggage is it's a concept I really hate in OpenTelemetry, but it's more or less some data that we want to pass around just through the life cycle of an entire request and have it on every event. So if you have something maybe like a session ID or a client ID, you just be like, give me everything associated with that from the top. So like if a user session ID is something you could use for that, and maybe you want to know what's every single request that hit our system associated with that user, because we want to figure out what bubbled back up to the front end and caused an issue for them. That'll let us do that. In this case, we just do packages. I feel like there's definitely some Java heritage in here. But this propagator and this context trace map, trace context text map propagator is doing a lot of work to basically just generate an HTTP header that we can pass along to requests, and then stuff like the fast API instrumentation will actually look at incoming request and pick that up and notice that hey, this actually isn't a new request. Conceptually, this is downstream of some other trace. So I'm gonna go ahead and start these.
ls of dash I 8080. You might have to do dash I colon dash I. Same. There you go. And then kill dash 2 and then kill the PID.
That's annoying. Kill 2.
Yeah, that's sense again.
Okay.
Hey, there we go.
There we go. Thanks, Howard. I ran into that earlier too. Okay, so then you're making the same request from earlier. In this case, we're telling it's our hello world from our service A. And if we go into here, oh shit, we can see, it's gonna take just a second.
I want to see those headers.
I just wanted to make sure about something here. Oh, shoot, sorry, I ran into this one last time too.
Sig winch is when the terminal resizes.
Oh, sorry.
It's how your Vim terminal knows that you resize your windows.
Okay,
Wait, can you?
that got me last time too.
Okay, those are their headers.
Yeah, so that baggage and that trace parent header is being sent to the other Fast API application as headers in our request. So trace parent is just in a format that tells us like, hey, this is an existing trace. Do with it what you will. And this can actually be kind of an issue with other people's tracing if they're not smart about it.
Because what if they had like also an HTTP header called trace parent?
Yeah, so you have to be a little choosy about that, and then
Okay.
you're just saying, hey, this is something that was from upstream, go apply it to downstream requests, and now that I have my environment configured, I think we should see some better downstream requests here, so let's see, maybe.
Does this have an option to generate like a graph for you of where all your network calls are?
Yeah.
Oh, that's sick.
Oh, shit. All right. Not that works. Oh, that's a problem, yeah. So. Wait, let's see. Here we go, we got a distributed trace. So you can see, this is our services A, and then in the context of this one, you get a view of our service B trace. And then you can also, I believe, view those in their own context. Yeah, I had the time wrong for that search. That's why it didn't show up. But and how this is visualized really does depend on what service or vendor you're using. But and as you can imagine, in any real application, there would be a lot more fanning out going on here.
Okay. Huh.
Okay. So I'm gonna do one more thing, and then I would love to answer any
What is the next part about?
The next part is about kind of a relatively newer part to this, which is events, which are kind of a middle ground between a log and a trace. It's something that happens at a point in time and has no, it has no duration associated with it, so it's really useful for if you want to have some, okay, I think this one should have an event associated with it. Yeah. So as you can see here, we have a span event, and you want to just mark something as having happened on this particular span with kind of enough context for it to be its own thing, but not necessarily something that has like a time span associated with it. You see those as exceptions a lot. We want to record some exception data, and maybe you have multiple exceptions running in a loop or something within a span, so you could just have an event for each one of those. Although typically, each, or whatever calls them would probably have its own context. And then for some fun, I am going to pull whatever the longest trace I can find from some of our order logs. Hold on. Let me change this a bit so it's annoying. Traces, standard. Oh, okay. I just want to say, let's see. There's something where we have an error in a few of the traces. Actually, here we go. Yeah, there's no PII in here, but I mean, this is probably a more realistic example of the kind of data you'd be getting out of here, where you have a call to maybe a couple web services, and one of those does a fan out to a queue here. As so you can see, the bars on this are a lot smaller, because we have traces that kind of keep going after the parent trace actually ended, and also are just across multiple services. So here we have some, oh gosh, I think this was just some network connectivity to AD, so you can see as basically this process on a queue just keeps getting retried. And there's an exception, so it gets marked in your observability tooling.
Is that I apply async the celery call?
Yeah, that is celery. So
Okay.
it's a celery queue that we're running here.
And you can query the trace through Honeycomb?
Yeah, and really the coolest thing about it is you can query any of this data. So if you wanted to find something by a session ID, or just do metrics on like how long did things take, it's really good for that. Also really, let's say, just do a kind of a heat map visualization on duration, and then just group by, let's say, generic route, we can say. I think we got some real outliers there, but nothing really terrible. actually, let's do average. You see, like, what calls are really the longest. You can see it, like, that one can take up to a second, which makes sense because it's doing a lot of work. So yeah, it lets you just
It's calculating how much of your soul to sign away.
yeah, but no, it lets you just do a lot with the data you have, and just get some really good actionable insights out of it. It's like, or do something maybe. Let's see, count errors. Error exists, but we want to group by route and say, what of your API routes is producing the most errors at the top level? Let's go look at this.
This is nice. This is cool. This is cool.
So yeah, anybody have questions about like how you would use this in your own applications, or just
We have Grafana that's monitoring all of our like infrastructure, like system uptime and stuff like that, CPU usage, memory usage.
yeah? So what's the ingest for that like look like?
What do you mean by ingest?
Oh, I might be thinking of InfluxDB. Never mind. So Grafana does like the metrics collection on there.
No, Grafana is just a dashboard visualizer.
Okay.
It uses exporters to scrape statistics. Right. So you have like you have something called a node exporter, and node exporter basically just looks at your system's like process CPU time usage, and then it sends it over to Prometheus, and then Prometheus does something with it, and it makes it and it formats it in such a way that Grafana can understand it. And then
Gotcha.
Grafana is you can also perform queries with Grafana. So like if you want to say I want to get the CPU usage of this specific machine, and you can perform a query like that. But that's not at like an API level kind of telemetry data. That's like your system level telemetry data.
Oh yeah, and this isn't necessarily at an API level. Like you could get this data at the container VM level,
Right.
Depending on whatever kind of agent or collector you're in.
Okay.
Really, the idea around of it is everything just speaks the same language on what this stuff should look like. So when you're ingesting it, it's easy to work with it.
Mm-hmm.
But yeah, it does seem like everything under the sun in the observability space is moving towards OpenTelemetry.
Wait. So what's happening with Grafana and telemetry?
I was just curious if they had anything about it. So it looks like they do support that OTLP now. So
Okay.
if you can look at OpenTelemetry collector, you can point it at Grafana now.
Nice.
And I do believe your collectors can also do stuff like CPU usage.
Okay.
At least for what they're running on. And if you're using something like, I think it's FluentBits, I'm actually really curious if they use OpenTelemetry now. Yeah, so another really nice tool that I use sometimes, and it's just like a little C program. You run it as an agent on whatever services you have, and yeah, you can point this at OTel now, or at a vendor or collector, and have that running on it where the performance impact would be lower, and then let your collector deal with just buffering everything and handling the bulkier data.
Neat.
Cool. Yeah.
Neat.
I'm kind of curious if anybody has like applications you'd want to know more about of your own.
I feel like if you have any sort of web server, you would want to use this.
Yeah. The only thing I would be worried about just is cost, because the egress cost of observability can be a little high, especially if you're in the cloud. I think Honeycomb is all in on AWS, so you might just get like cross AZ charges versus like actual egress costs, depending on how
Why
you do
would
that.
you have? Why would you have egress cost?
Well, essentially, so you're sending your data out of the cloud and then maybe back into the cloud.
Right, but what data are you? Is it the information like pulling this graph would count as egress cost?
Oh, not pulling this graph, but getting all this information from your application into whatever's generating this graph.
Isn't that ingress? Wouldn't that be ingress cost? Like ingress?
Well,
is
it'd be
free.
ingress for them, but it would be ingress for you.
EC2 on an EC2 server somewhere.
Okay. Oh. I see. So if you had like Honeycomb running on something, and then you had your application running in EC2, the fact that you're sending something out of that EC2 instance is going to count as egress.
Yeah, depending on how you do it and whether it goes through the public internet, I am not super familiar with cloud networking. I know there is some way to kind of sidestep that, but we are kind of screwed just by the way our network architecture is, because everything goes basically out through Tucson and then back into the cloud.
Well, that is the hour. Does anybody have any more questions? I know I asked a lot of questions.
I appreciate the questions.
Yeah. All right, cool.